Good morning. Today we will discuss about the Mealy and Mealy machine. So first of all, we will discuss about the finite state machine, FSM. This is also known as FSM. A finite state machine is a machine that has many states and has a logical way of changing from one state to other under guiding rules. It means that we are changing from one state to another state using some rules. Without any rules, we cannot move from one state to another state. At least we have some rules to show the movement from one state to another state. Now, types of FSM and types of finite state machine. The first one is finite state automator. Second one is Mealy machine. Third one is Mealy machine. On which we are emphasizing on the Mealy machine and Mealy machine. We are ready. Now, this is Mealy machine. This is a Mealy machine is an FSM basically, whose output depends upon the present state as well as of changing from one state to other state under guiding rules. There is some rules, same kind of patterns. We are following the rules from changing from one state to another state. And this is the basic definition of Mealy machine. Mealy machine is basically defined by the 6 tuples basically. The first is Q is the finite state of the states. Second one is sigma. Sigma is the finite state of symbols called input alphabet. Third is O, capital O. Sometimes it is written like a triangle. Is a finite set of symbols called the output alphabet. Fourth is delta is the input transition function from delta. That is input state multiplied by sigma is equal to sigma. X is the output transition function. This is transition function, that is rule basically. Q0 is the initial state where any input is processed by Q0. This is the transition table diagram. This is transition. We can understand by the table also. The table consists of the present state as well as the next state. The present state means, it is showing present state means this is Q0. Q0 is the present state at which we can change to Q3 as well as Q1 by using input. Okay. This is suppose A is equal to, there is two input, A is equal to 0 and A is equal to 1. Two input is there always in this group. First of all, at Q0 state, we are going to getting the output 0 when input is 0. We are going to Q0 to Q1 when the input is 0 and output of that time is equal to 1. Similarly, at Q1 state, we are moving to Q0 state, getting the input 0 and same time we are generating the output 1. Similarly, at Q1, we are getting the input 1 and generating the output 0 and we are also moving to the state Q3. So we have total 4 states, Q0, Q1, Q2, Q3. At Q3, Q2, we are going to Q2, same state. This is on same state, we are retaining the state by using the input state, input value 0 and output of this state is 1. When the input is 1, is it again maintaining the same state and output is equal to 0. So this is the value when the present state is dependent upon the next state. Using this same time we are dependent upon the output also. This is the Mealy transition table. Now go to the next value, next slide. This is Mealy machine. The next part is Mealy machine. Mealy machine is again divided by the same six kind of tuples. The tuples are same as the Mealy machine. Q, sigma, delta, triangle, delta, lambda, Q0. Q is equal to finite non-empty set of states. Sigma is equal to set of input alphabets. Triangle is a set of output alphabets. Delta is a transition function mapping Q multiplied by sigma, that is Q. Lambda is equal to output function and Q0 is the initial state. In here, what is happening here? See, this is the Mealy machine. This is Mealy machine. In Mealy machine, what we are doing? In Mealy machine, the present state and the next state and output is only 1. output is only 1. There is no output, like a Mealy machine is generating this output nearby the next state. But here we are generating only one output. So at Q0, getting the input value 1, going to the Q3 state, at Q1 is equal to Q0 is 0, Q0 getting the input value 1, and going to the Q1 state, the output is generated by 1 only. Q0 is generated 1 as an output. Similarly, Q1 is going to Q0 and Q1 is going to Q3 with the output is 1. Now, at Q2, similarly Q2 is going to Q2 at 0 and going to Q2 at 1. Output is, for output for the Q2 output is 0. It means that indicating that Q0 generating the output 1, Q1 is generating the output 0, Q2 is generating the output 0, Q3 is generating the output 1. Nothing else. Isn't it? So go to the next slide. Now this is the main task started. This is conversion of machine from one machine to the second machine. Now here first we are going to convert the Mealy machine to Mealy machine. So first of all go back and check the Mealy machine. Mealy machine have one output. Where rather than Mealy machine having two output and output. So we are going to convert one Mealy machine, one output into two output. We are converting we have the Mealy machine. Mealy machine have one output and we are going to convert into the Mealy machine. And that Mealy machine have the two output. So this is the steps required. Input is Mealy machine. Input is Mealy machine. Sorry, this is some back. No, save. Go again. Input is Mealy machine. Output is Mealy machine. Take a blank Mealy machine. First of all, we will take the blank Mealy machine as it is a Mealy machine, just as the design based on the present state to the next state. Step number 2, copy all the Mealy machine transition states into this table format. We have to copy the transitions of the Mealy machine into the Mealy machine directly. First, we will copy all the details. Third step, step this one. Check the present state and their corresponding output in Mealy machine state tables. If for a state Qi, output is M, copy it into the output column of the Mealy machine state table wherever Qi appears in the next state. It means where we are getting the next state, copy the output value like C. This is the present state, this is the next state, this is the output. It means, what it means, at the value A, we are getting the output 1. At the output B, we are getting, at the value present state B, we are getting the output 0. Means C, getting the output 0. At D, getting the output 1. So what is happening here? At A, we are getting output 1. At B, we are getting output 0. C, we are getting output 0. D, we are getting output 1. There is nothing else. So first, we will copy this to the Mealy machine as directed by the rules. So we have made the Mealy machine like present state, next state, A is equal to 0, A is equal to 1. The present state is written A, B, C, D. Now the next state is written D, A, C, B, C. Here D, A, C, B. Now next at A is equal to 1, we have written again B, D, C, A, same as this one. B, D, C, A, isn't it? Now what is happening here? There is two output. At A is equal to 1 and D is equal to 1. Other than that, that is B and C, this is 0. So come. So we have to fill this gap. We have to fill this. So what will happen? We will write here, right? At A is equal to, we are getting the output D, we are getting 1. At A, we are getting 1. At C, we are getting 0. At B, we are getting 0. At B, we are getting 0. D, we are getting 1. C, 0. And A, 1. This is the complete Mealy machine. After designing, derived from the Mealy machine. See, what is happening here? See, this is the answer. 1 1 0 0 0 1 0 1. At A, we are getting 1 because we have the output. At A, we have the output 1. See, at A, we have the output 1. At D, we have the output 1. Other than that, both are 0. So At this table, we are getting, where we are getting D, we are writing 1. At A, we are writing 1. At C, we are writing 0. At B, we are writing 0. B, and we are writing 0. D, 1. C is equal to C, at C, 0. A is at 1. This is the total conversion of Mealy machine to Mealy machine. Now, come to the next. This is again the reverse conversion, Mealy machine to Mealy machine. This is also very important topic. For this, we have the next steps. First is input. What we have the input as in the question. Question given in the format. The machine is given in the format of Mealy machine. So we have to generate the Mealy machine. We have to convert the Mealy machine into the Mealy machine. Means we have the two output. We have to convert into the one output. Calculate the number of different outputs at each state QI that are available in the state table of the Mealy machine. Next is the if the output of QI are the same, copy of the QI, it has a distinct outputs break QI into any states QI in the other than 0, 1, 2. So what we are getting here, we are doing this. Suppose at Q0 we are changing the output in the Mealy machine. We are in the Mealy machine we are changing. Suppose at the same time we are getting the two outputs. At Q0 we are getting the 0 also, and Q0 we are getting the 1 also. So at that moment of time, what we'll do? We'll do convert the Q0 into two parts. This is in the 0 format and the 1 format. Means what it means? It means, suppose this is a table. Let us consider the Mealy machine. This is basically a Mealy machine where two output is given, output and output. See how we are converting. This is very important. I have written also here are some states A and D. The state A and D. This is state A and D. A and D. Where is the A and D? So we will write A and D. This is A. This is D. This is A. Okay. So now we are getting A 0 and A 1, A 1. Same output. Okay. And D is getting 0. D is getting 0 output. No issue. At A we are getting 1. At D we are getting 0. Now for the B and C. B, what we are getting at B? We are getting B. This is 0 and this is 1. We are getting 0 and 1. So this, how we write? This is like B0 is equal to 0, and we will divide the B into two parts like this. For 0 we will write the 0. For 1 we will write the 1. Isn't it? So next part is output is C, like C. So we are getting C and the value is 1, C the value is 0. It means we have the same problem. C have two outputs 0, 1. So we will write the C0 at 0 and C1 is equal to 1. So we will divide it. So how many states we have added? We have added 1, 2. We have two states A, B, 0, B1, C0, C1 and D. Before that we have the only four states. This was A, B, C and D. Now we have 6 states. We have added the 2 states. So come to the next slide. This one. This is, so see this. At A we have the one value 1. Here we have it at A. So what is the value? At A we are getting 1 only. So at A we are getting 1. So at B0, B1, C0, C1, D. This is 6 state we have written. 6 state. Okay. There is no problem in the A line. A, B1, 1. How we have made it? This is D, 0. This is written D. Okay. Only the state is taken. So D is state. The next state is B, and output is 1. So what we will write? We will write B1. B1. The output at A is equal to, what is the output at A? 1. So we will fill the gap and at output we will write 1. 1 here. Next state is B. B is, previously that was a single state B. Now the B is divided into 2 states, B0 and B1. So we will take the B0 and B1. First we will take the column value, the row value. This is A and D. Both are the common. A has the no change in output, D has the no change in output. So we will write A and D, A and D. The output at 0 is equal to 0, output at 1 is equal to 1. Again, C0 and C1. C0 and C1. This is C1, C0 is written here, output is 0, C1 output is 1. So what is happening here? See, C1, C0, C1, C0 means C is generating output 1, C is generating output 0. So how will write it? C is generating output 1, C is generating output, let's copy this, C0 and C0, 0 and 1. Similarly for D, there is no change in D. D, B0, B0, it means B0. Output of the B is 0, so we will write the state B0, B0. This is A. A is written simply A. We have written taken A only. And D, the output we have got the output as output at D is equal to 0. So we will write D is a 0. So this is the total machine where we have converted. So what is the basically this is the next state we have added. This is the state added. We have the state added. Rather than this is writing B, C, D, and this is the output, single output we have added. This is the basically machine we want to convert it from this side. Come to the next slide. This is differences between Mealy. What is the difference between Mealy and Moore state machines? Basically the difference. What is the difference? Output depends on both upon present state and the output depend upon the both present state and present input. Here the output depends only upon the present state in the case of Moore machine. Generally it has fewer states than the Moore machine. Generally it is using more states than Mealy machine. Because we are going to add some data, some states, that's why the states become enhancing. Output changes at the clock as is. Input changes can be changed in the output changes as soon as logic is done. Isn't it? Next is Mealy machine react faster to the inputs. Mealy machine is reacting to the faster than this. Moore machine's logic is needed to decode the output since it has more circuit delay. Due to the extra states becoming the circuit is delayed available due to the circuit. And this is the advantage of Mealy machine and Moore state machines. What is the advantage? Moore machines are cheap. They are easy to use. Moore state machines are very fast. Mealy machines are reactive. If they have a low response time, they are fast. This is disadvantage of Mealy and Moore state machines. Mealy state machines are expensive to produce. Number of states can become unmanageable. They become too many. Now, this is the almost we're about to finish about the Mealy and Moore state machines. What is the use of this Mealy machine and Moore machine? So, Mealy state machines are used in a processor due to their property of having many states. Mealy state machines are also used to provide a rudimentary mathematical model for cipher machines. A Moore state machine is used to enable SRAM because of its speed. We are using the extra speed in this. That's why we are using this Moore machine. Now it is a SRAM because SRAM needs a level sensitive control signal as to asserted for an amount of time. Due to the SRAM, because we are giving this faster speed in the SRAM, that's why we are using this machine models. Conclusion is this. In conclusion, Mealy and Moore state machines are very important concepts in digital design. Whenever we are designing the circuit, these are very important to design the Moore and Mealy machine with what we will use. These state machines can be used in the design of mathematical algorithms. Whenever we are designing mathematical algorithm, we are using to design use this concepts. Mealy and Moore state machines can come in both simple, having one input and output, to complex, having many input outputs to many types. And because we can use them in both simple and complex data we can use it. Next is, thank you. for the slide? Listening? Okay.